Hello everyone, welcome to lesson 5-4, terminating and repeating decimals. Terminating means ending, that the decimal ends, and repeating means they continue to repeat indefinitely. You can find this lesson on page 379. Any number that can be written as a fraction is called a rational number. Every rational number can be written as either a terminating decimal or a repeating decimal. Now we know that rational number, boys and girls, are fractions or mixed numbers, positive or negative. We know that we can take those mixed numbers or fractions and write them as a decimal. A terminating decimal just means the decimal comes to an end. There's a zero. We don't write the zero. A repeating decimal means you get a bar notation. For example, the number 0.777, and it keeps going forever. 7 can be written as 0.7 with a bar notation. This bar notation implies that the 7 continues infinitely. So let's draw some lines from each word to its matching statement. Terminating decimals, what are they? They are the decimal form of a rational number which has a repeating digit of 0. So 0.6250000 continuously. But we don't write the zeros, right? So this would be a terminating decimal. It ends because the next decimal infinitely is 0. So go ahead and let's draw a line to match those two. And then, what is a repeating decimal? The decimal form of a rational number such as 0.333, and then you see the dot, that dot means it's going to repeat infinitely. So we write it as so on with a bar notation. Go ahead and match. Please write this 0.3 bar notation there as a key answer. Real world link. Party favors. Jude is buying fruit snacks for party favors. Party favors are the gifts you give to people at birthday parties or so on. He asks the cashier for a ½ pound of fruit snacks. ½ pound. Express 1/2 as a fraction. There it is in the simplest form, right? ½ pound. 1 part of 2 parts. Write the decimal that represents ½ pound. Well, we know that we can write that as a decimal as 0.5. It's half of 1. Suppose Jude wanted to buy 1/3 of a pound. What decimal would the scale show? Okay, 1/3 of a pound, it would show as 0.3333 infinitely, right? Or we can say 0.3 bar notation. You can write both of those. Now, we know that 1/3 is written as so. 1/3, 1/3, 1 out of 3. Please write all 3 forms of this of 1/3. A quick review of what rational numbers are. In words, rational numbers can be written as a fraction. We know that. Algebra, in algebraic words, it's AB, where A and B are integers. Integers meaning numbers, whole numbers, right? Positive or negative. And B cannot equal 0. The bottom number, the denominator, cannot be 0, otherwise the entire thing, the entire value is 0. Here's a model. We have rational numbers. The simplest one in the middle, they're saying it's whole numbers, but it's actually not. Before or smaller than whole numbers, we have natural numbers. And natural numbers is like when you were little and you learned to count, or when you have pencils in your hand, you start counting them as 1, 2, 3, 4. The natural way to count, right? Natural way to count. But then we wanted to add a 0. And when we added the 0 to the mix, okay, right there, the 0 that I just added right here, then we decided to call them whole numbers because we added the value of 0. Then we added to whole numbers, we added negative numbers, and we started calling them all integers. Everything is an integer. But then we added fractions, positive and negative, and mixed numbers with decimals. So then now the whole thing, all those numbers, including integers, whole numbers, and natural numbers, they're all called rational numbers. So fractions as you see here, fractions, terminating and repeating decimal, percents, and integers are all rational numbers. Everything, okay? Anything that is a fraction of a number, a decimal, a mixed number, percent, remember percent it's a fraction of a number. They're all rational numbers. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. So you know that if we have a fraction, such as a half, right? If we were to divide 1 divided by 2, we're going to get 0.5. And that's how we can convert a fraction to a decimal. But sometimes when you divide the numerator by the denominator, you're not going to get a nice terminating decimal, right? Sometimes you're going to get a repeating decimal. So to indicate the number pattern that repeats indefinitely, use bar notation. Bar notation is a bar placed over the digits that repeat. Sometimes it might be 1, sometimes it might be 2. Look here. We have 0, decimal 5-4, 5-4, 5-4, infinitely, right? So we put the line over both, the 5 and the 4. And then when you look here, we don't have any decimals repeating yet, not yet, and then the 3 starts to repeat infinitely. So we only put it over the 3. And here we are converting from a fraction to a decimal to a terminating decimal. Okay, do you see that? And we did that by dividing the numerator by the denominator. Divide the numerator by the denominator, and so on. Here I would have preferred, instead of saying does not terminate, I would have written it as 0, decimal, 8, 3, bar notation over only the 3, right? By the way, that's a key answer, so please write that right on there. So here we have a fraction, and we know that we can divide the numerator by the denominator. So we have 5 under the little roof, which is the dividend, and then we have the divisor, the number that it's being divided by, so it's 5 over 12, so 5 divided by 12, and you do your long division. Now don't forget that you ask yourself how many 12s are in 5, there's none, so you put a 0 and then you put a decimal, and you turn this to 50 and you start to work there. 12 times 4 is 48, and so on. Okay, if you need to review long division, please ask me in class and we will do it. And now you can see that 5 over 12 is a decimal with a repeating 6, so we put the bar notation over the 6. Okay, for a lot of you this will be a review where you have to convert these fractions into decimals. So go ahead, pause the video and try it now. A little trick that I want you to remember is this one right here. Any number over 9, you see this right here? Any number over 9 becomes this number in the 10th place, right? Bar notation. So it becomes this number, bar notation, meaning you'll have 0, decimal 8. So you see the number is in the 10th place, bar notation. And you can do that with any number. For example, if you have 2 over 9, it would become 0, decimal 2, bar notation. And that's a nice little trick to remember. It saves you some time. Another trick to remember happens with 11. 11 will also be bar notation, but 2 decimal places bar notation. I'm not exactly sure which 2 numbers. You still have to do the division because the number changes every time the numerator changes, but it's always going to be 2 number places bar notation. Okay, you can start by setting it up now where we have 1 divided by 6, and we know that there is none there, so we make it 10, and now 6 into 10 is 1. We have 6, 4, bring down the 0, and it will be 6 here to make it 36. And now we have 4 again. Oh, it's going to continue to repeat itself because now I'm going to do another 6, right, to get 36 again here. So what's going to happen is it's going to be bar notation with the 6. So my answer is 0, decimal 1, 6 bar notation. Over here we already established that it's 0, decimal 8 bar notation. So we have 2 divided by 11. 2 divided by 11. Remember, the number that's being divided goes under the little roof. There are no 11 in number 2, so we turn it into 20. I have 1, and now I have 9 left. Okay, 9 when I subtract. And now it's 90, and 11 times 8 is going to be 88. Now I have 2. Okay, bring down the 0, and you see it becomes 20. So I'm right back to where I was before, 20. So then I do another 1. What's going to happen? I'm going to get again 11, right? When I do 1, I'll get 11 again, and then I subtract, I get 9, which is 90 again. So what's going to repeat is the 1, 8, 1, 8, 1, 8. This is what I'm going to end up doing over and over. You can keep trying it if you like, but you'll notice that you'll continue to get 1, 8, 1, 8, 1, 8. So what do we do here? We write it as a bar notation. We write 0.18 because they both repeat. Write a negative fraction as a decimal. When writing a negative fraction as a decimal, the process is the same. Divide as with positive fraction. Write the negative sign in front of the decimal. What they're saying is, for example, we did the example of a half. Okay, but if it changes to a negative, all you have to do is just take that negative and put it right back in your answer because the value continues to be negative. So if you have 1 divided by 2, it's still going to be cut in half, right? You're cutting the 1 in half. So it's still just written as a half. A half as a decimal is 0.5. Now, if you're ever wondering why 0.5, you can just simply make this like a 10, the way you would do it when you're dividing. So pretend this is 10, and you take 10 divided by 2. But remember that you're actually dividing is 1. You're not dividing 10. But you can see that 10 divided by 2 is 5. But it's 5 in the 10th place. So your answer would be negative 0.5. It's the same thing. Just keep the negative. So here's the example. You see that it's now negative 9. Now remember a little trick I told you? Any number over 9 becomes that number, bar notation, and you can see it right here. You can see it right there, right? It became that number, bar notation. So really, all you have to do is just make sure that you know that it's a negative, and you add your negative in, right? There's your negative, and then you write 0.2, because it's a 2 right there, bar notation. That's really it. Don't forget the negative though. When you have a mixed number, there are 2 ways to do it. Okay, the one way the textbook is explaining here is to convert the mixed number into an improper fraction, where you multiply 3 times 2 plus 2. 3 times 2 is 6, plus 2 is 8. So really what you have now is 8 over 3, bar notation. So you're just going to divide now 8 divided by 3, the way we would normally do it, as you see right here. Okay, 8 divided by 3, and you get 2.6. An easier way that I think would be to separate the mixed number. Okay, you're going to separate the mixed number where you have your negative 2 plus 2/3. Right? You know that negative 2 plus 2/3 is going to be right there. So that's what you have. I'm just separating it for now. So that now you're just working with 2/3. And you know that when you count by thirds, you have 1/3 is 33 bar notation, or 3 bar notation, 0.3 bar notation, right there, okay? And 2/3 is 0.6 bar notation. So now that we know this, because we've divided and we tried it out, that it's bar notation, just add it back in. So now your equation should look like this, negative 2 plus 0.6 bar notation, which ends up being 2.6 bar notation. Okay, as you see it right there. Take a look at the word problem here on your own, so you can see the fraction that you have, 34 out of 44, and then it's divided and you get your decimal. Let's try the word problem. Oh, I'm just realizing I missed this section of the book as well, where we are doing the same as we did before, except now we're keeping the negative. So pause the video and try these 3 on your own. You should try something like this, okay, where you are taking the 1 divided by 4, divided by negative 4, 5, you see there, divided by negative 6, and 1 divided by 6. I put in the equation here, put the negative 2 already in place, so all you have to do is just solve for this and add your decimal place right next to the 2. For the first one, we have 1/4, and it's negative 0.25. For E, we have negative 0.83 bar notation. And for F, we have our negative 2, as I had before, decimal 1/6 bar notation. The bar notation is only over the 6. Sorry, it's a little long, but it's only the 6. Now we're ready for the word problem. Of 9 students surveyed, so I know it's out of 9, 4 said they prefer exercising in the morning rather than in the evening. 4. There's our 4. Express this fraction as a decimal. Use bar notation if necessary. Oh, we know it's necessary because it's right over 9, and we've already discussed that any number over 9 will be that number, right? Bar notation in the 10th place. And there it is. Please leave the guided practice for class so we can do it as a warm-up. But please complete the entire independent practice, including the back of the page. See you in class.